All right, so what do we need for this this first Fisher projection? Oh, that look good? Which version do I have written up here?
D.
Okay. Ketopentos. Does that look good for the next one? And this one's an L? Okay. So we're okay with the hydroxyl group that we're looking for is on the last chiral carbon, not just the last carbon. The way I have the hydroxyl group drawn on the CH2OH, is that D? Is this right here D?
No.
Why not? It's not chiral. It can move wherever the heck it wants, spin all the way around that. So there's no stereochemistry to that because of the double H's. Three common disaccharides. So most common one?
Sucrose,
Sucrose. And what's it composed of?
glucose, and fructose.
And what? The least common?
Maltose.
Lactose. Glucose and what? The maltose is the second most common just because we make so much grain in this country. And really it's just a grain that's been knocked down to two glucose molecules. Draw D-glucose, L-fructose, and D-galactose. What do these guys all have in common? All right, so D-glucose, I didn't really say which way we wanted to do it, so I guess a Fisher projection would do. Is that right? Down. Huh.
I think the second and third
Flopped.
carbon.
What are you doing? Erase. Cool. There we go. So there's my D-glucose, and then my fructose is CH2OH, C double O. Left and right.
So we do need to memorize these?
Negative.
We just need to understand all the little concepts within it.
Correct. So, let's go ahead and put the D-galactose at first. I think that's correct, so let's check. Nope, right, and then everybody's on the left. Yeah, no, that's correct.
The third carbon, all the hydroxyl groups are on the left.
It's D, you got it, that's L.
Oh, I got it in L. Oops. There we go. All right, so what do these guys all have in common?
They monosaccharides.
They all have the same chemical formula. Let's start there. So,
Did I miss that one?
what are they in relationship to each other? Be careful. What'd you say, Dan? Okay, they're definitely isomers. The middle one is a structural isomer from the other two. Okay? We all right with that? And the first and the last, the glucose and the galactose, what are they? Stereo isomers of each other. They are connected in the same fashion, it's just that the fact that there's stereochemistry associated with those. So glucose and galactose are enantiomers of each other, and fructose is not because it's a ketone, so it has a different structure than the other two. Okay, they're all monosaccharides, and they're the three things that make up the disaccharides and the three things that make up the polysaccharides. Monosaccharide, what's the main function?
Basic unit of metabolism.
The disaccharides?
Carry on.
Basically transportation from the liver to muscle. Actually, I'm not going to say that. I'm going to say liver to cells. And the polysaccharides?
Storage of monosaccharides.
If we're talking about in animals, it's just storage. But if we're talking about plants, it's storage and structure. More structure than storage. Why are the mono and disaccharides soluble?
Is it short chain?
Short, small.
Short?
Short chain or small. And what makes them soluble? Totally got that backwards. So how many of those OH polar bonds are there? 5 of them per monosaccharide, plus they've got an oxygen that's inside of the ring structure, so there's 2 more lone pairs of electrons that water molecules can attach themselves to. So there's lots of places. I mean, for something to be soluble, it means it's aqueous, and for something to be aqueous, what has to happen? The water needs to be able to do what?
Break bonds.
No, it doesn't need to break bonds. It does that with soluble ionic compounds, but it doesn't break any bonds in the glucose. So what does it need? It needs to be able to interact with the molecule. And so if you've got 6 places on each monosaccharide to interact with, then the water molecules just float around that and interact with it very easily. I mean, you can dissolve a lot of sugar into water. So there must be a lot of places for the water to interact. And that is the fundamental difference between aqueous of a molecule and aqueous of a salt. So a salt will go in, separate into its anion and cation, and the water molecules will attack that. This glucose, fructose, or galactose, or sucrose molecules, they do not break apart, or they do not break chemically apart. The water molecule just takes the entire glucose molecule and solubilizes the whole thing. So there aren't any broken bonds.
What about with an alcohol?
What about
Is
it?
it just soluble, or is there an actual chemical reaction going on when you have like water and alcohol?
No, it's just soluble. Yeah, the hydroxyl group is attracted to the
Yeah.
the OH bond, hydrogen bond on the water molecule.